something brand new. And we want to be able to multiply some number or term by a polynomial inside a bracket. So some expression, some language, vocabulary you need to know. If you see here the term expand, basically expand means get rid of the brackets. Okay, I said eliminate because I was being polite, but you're getting rid of it, right? So in this case, you don't need to understand how I got this answer yet, but the point is that this here would be what you call factored form, something like that. Expanded form is like this, no brackets. These two are equal to each other. You'll see why sooner. You might be able to figure it out just by looking at it, but expanded form means no brackets. So how do you do it? Well, you apply what we call the distributive property. And the distributive property just means you distribute, you actually take the 2 and you multiply it by everything inside the bracket, every term. So in this case, you'd multiply the 2 times the x to get 2x, the 2 times the 1, 2 times 1, which is just 2. And that is the expanded form of that polynomial. And that's distributive property. Okay, similarly, just a little thing about the signs. Signs get confusing, but it's kind of like, well here, the first part's easy. Minus 3 times x is just minus 3x. You have to think of it this way. You're doing minus 3 times minus 5. Minus times a minus is a positive. Okay? I think that's hard to, I don't know, you just got to do it. Think of it as you're multiplying it by the whole thing, minus 5. Not subtract 5, but minus 5. And then it becomes positive. Okay? Nope, that wasn't it. Sorry for that one. Okay, so we're expanding. We're getting rid of the brackets. This one here, I just rewrote it. You don't have to, but it makes more sense. You should have the single term out in front. Okay? So that's minus 5. And then minus 5 times 3x minus 5. And now you distribute the minus 5 through. So minus 5 times minus 3 is minus 15 times the x there. Minus 5 times minus 5 is positive 25. Okay? Similarly here, ooh, messy. I rewrite it with the 1 in front. And minus 1 times minus 4a is plus 4a. Minus 1 times minus 4 is plus 4. And minus 1 times plus 2 is minus 2. Bigger one, but really the same idea. Now I just multiply by 3 different things, right? 3 times 2 is 6, so that's my 6b squared. 3 times 4 is 12, that's my 12b. And 3 times minus 5 is minus 15. Okay, sometimes there can be an x or a letter out there. And this is where you have to remember our exponent rules, the product rule in this case. 2x times x is 2 to the x1 times x1, so that's really 2 to the x squared. Okay? 2x times minus 5 is minus 10x. Okay, so sometimes that comes up fairly frequently, I would say. Another one, n times n squared. Well, n times n squared is n cubed, right? Because it's n to the 1 times n squared. So using the product rule, that gives you n to the 3. N times minus 2n, the minus 2 doesn't change, but the n becomes squared, right? n1, n1, so minus 2n squared, and 4 times n is just 4n. So you'll definitely see some of those. Okay, so here's an example where we have lots of stuff going on. We're expanding and we're collecting like terms, and the expanding part, I guess you follow that step first. You get rid of the brackets by applying distributive property. And then you, after you've done that, you collect all the like terms and simplify it. Okay? So, over here on the side, if you take a look over here, I wanted it to be very clear that you, when getting rid of a bracket, you must multiply the term out front by each term inside. So you could say this, and you could say this, right? These two are correct statements if you're just dealing with numbers, because numbers and letters, they follow the same rules. The common mistake, and that's why I put this here, is that sometimes people multiply the 2 by just the first, like in this case just the 5, and not by the 2 as well, and that's the common mistake, right? And it doesn't, and you can see it doesn't work out to the same thing. Okay, so that's distributed property looking just at numbers, and it follows the exact same rules as if there's letters. Anyway, so back to here. 2x times x is 2x squared. 2x times minus 5 is minus 10x. Minus 3 times x squared is minus 3x squared. Minus 3 times plus 2 is minus 6. Okay? So here, it's interesting because it's a subtract. And the way you think of it is you just, this is distributive property. And distributive property of minus 3. Minus 3 times each term. Okay? Then you collect your like terms. Get all the, remember that minus. When you're collecting your like terms, this minus will follow the 3x squared. That's that one there. That minus will follow the 10. That's that one there. That minus will follow the 6. And 2 minus 3 is minus 1, so you can write minus 1, or excuse me, more simplified is just minus x squared. Minus 10x and minus 6 don't change. Okay, this one we're going to do when we get to class tomorrow, just because, as you can see by looking at it, it's a little harder, and we'll save that for class time. But that doesn't mean we're not going to do the next one, okay? So the next one is brackets and brackets, and what I mean by that, sometimes, like, what do you do when you have all these brackets, right? And the main thing is that first, if you see from a form communication point of view, your outer brackets will be square. Not that that affects how you solve it, but it looks better, it makes it obvious what's going on. And what you do is you just do everything. I'm going to separate this because it's important. You do everything that you can inside the square brackets before you do everything you can inside the square brackets before you deal with anything outside the square brackets. Okay? So you pretend almost like this problem was just this part here, 3x plus the 5 bracket x minus 2. And how would you simplify that? Okay, and you would do that by 3x stays, and then you do distributive property, so that's 5x minus 10 is a distributive property. 3x plus 5x is 8x minus 10, and then at the very end you deal with the square brackets, right? 4 times 8x is 32x, 4 times minus 10 is minus 40. Okay, so when you have brackets and brackets, you sort of leave the outside brackets and do everything on the inside that you can, and then at the very end you deal with the outside brackets. Okay, so let's look at the next example. Same idea, right? So I'm going to leave the minus 3 and the square brackets, not touching them, but I did right away apply the distributive property in here. So I've got minus 6 times a, which is minus 6a, minus 6 times plus 1 is minus 6, okay? I'm going to rewrite this same expression with the minus 6a out front. That's just proper form. So I put the minus, just, nothing has changed, right? The minus 6a goes here, the 2 comes here, and the minus 6 stays there, okay? And that just is the right form. Then I've got plus 2 minus 6 is minus 4. And then I can't simplify inside the brackets anymore. So once the square brackets, I've done as much simplifying as I can. Then I distribute the minus 3. So minus 3 times minus 6 is plus 18. Minus 3 times minus 4 is plus 12. Okay, and that's I think that's it for this one. Yeah, that's it. So that's the last little bit on distributive property, and we'll do that hard example tomorrow in class.